Hello, everyone. This week is week 5. In the last 2 weeks, we spent 2 weeks to explain the usage of a spreadsheet. From this week, we move to a new topic, software, operating system, and security. And here's the outline of today's lecture. So I will firstly introduce the software, and then our operating system, followed by the digital security. So you are encouraged to go through the following materials. And also, if you find some other relevant material online, that's also okay. So let's start with the software categories. So about the software category, if you remember this architecture we introduced in week 1, so that is general structure of our computer system. So at bottom we have hardware, so we have introduced that in week 2, and then we have our system software and application software. So these are the two main types of our software. So the system software is used to control and coordinate the procedures and functions of computer hardware. And that is application software. So application software is any program that is designed for end users. So what is the application software? So as I mentioned, application software is a program designed to make the user more productive and assist them with a personal task. Actually, the application software is the software we are using every day, like the internet browser, like Firefox, Chrome, Edge, Opera. So that's one type of application software. That is like the multimedia player, or text editor, or Dropbox, the cloud software, yeah, or the image editor, or the antivirus software. So any kind of software you are using every day, they are like 99%, they are application software. So within application software, we can further divide into several other categories. First is called productivity software. So for a name, productivity, it means that we can use it to improve our working or study efficiency. For example, the Microsoft Word, we can use it to help us to prepare the documentation. PowerPoint is used to make beautiful slides and help us with our presentation. Excel, of course, we just learned to deal with the spreadsheet much easier. The database software to deal with data, like data processing, data analytics. Also, there are many professional software such as accounting software, so help the accountant to deal with the numbers, calculate the text, and also like support software you have with the IT support desk to give a more efficient and real-time IT support. Even the customer is far away from the office. So even within the productive software, we can further divide into personal productive software and enterprise productive software. So for the personal product software, just like we just mentioned, so it's more to have our personal task more efficient, like documentation, spreadsheets, data processing, or even the finance, like the calendar. But for the enterprise productive software, is more on the enterprise level. It's more related to management or enterprise level service. So which is very different, such as like a human resource software, or like enterprise like service or marketing or sales or customer service or enterprise level IT software. So they fall into this category. So the next category is called graphic and media software. So this type of software is for a name. We can see that it's more for image and multimedia processing. So for example, we can use this software to do CAD design or 2D or 3D design as well. And also you can use this software to edit your photo, video, your audio. So if you are a YouTuber, probably you are using this kind of software like every day. So the next big category of this application software is called communication software. So this kind of software are used by like most people every day. For example, the browser. So if we want to go to internet, first thing that we open the browser to read news, to even we can watch the video, listen to music, send emails. Yeah, we can do a lot of things about the browser. And also for the chat software, it's also like always popular. So many years ago, there's a chat software called ICQ, which is totally disappeared these years. Then it's MSN or Messenger, some many chat software. Like they have an email, so like Outlook, file transfer, like internet phones like Skype, yeah, right? So even the mobile messaging is also communication software. So like a video conference, just like Zoom. So yeah, that's communication software. So that is all about application software. So next is called system software. For system software, we can also further divide it into several types. So first is called BIOS, so basic input and output system, and that is a device driver. Then it's our like operating system, utility program, or even the programming language like translator, compiler, debugger, and assembler. So you will notice all these subcategories system software, they all directly deal with hardware. So for example, some of the BIOS. So without the BIOS, even you cannot even turn on your computer. And also for the device driver. So without device driver, you cannot use your newly installed hardware because this device driver will nurture the new hardware to be recognized, and you can use all the functions about new hardware. Operating system, so that's the bridge between us or between the application software to hardware. So all this application software we just talked about, they all should be installed in the operating system. Utility software is something like a little different. So the utility program or utility software is used to maintain our system, to make it more stable or more clean, something like that. And next is the programming tools. So for the programming tools, so you should know that all these software are made or programmed by the program tools. So if we deal with hardware to software, so programming software is the first software where we should use. So first, let's start with our operating system. For the operating system, we have several types. First, desktop operating system. So it is used for our laptop, desktop, or some other tablets. Second is called the server operating system. So this kind of operating system is only used for the big server or supercomputer. So last is the mobile OS. So it's more used for our like the cell phone or some other mobile devices. So in the first desktop OS, is a category we have the most popular OS called Windows from Microsoft. So I will say majority of the machine in the world, they are using Windows. So one main reason is that many machines you come to hand, they have the Windows pre-installed. So that's kind of a commercial thing. Later we have the Mac OS, which is from Apple, and it can be only used in Apple machines. So you can install Mac OS in some other regular desktop, but due to the architecture, it is not easy. So we may have some like many driver problem or system stability problem. But still, if you're like interested, you can try to install macOS in your regular computer. Then we have a Unix and Linux. So these two OS, they are open source. It means that you can get involved in this OS development, and you can write your own code, write your own function, and it's free of charge. So that's why these two OS, they are mainly used by experts, professionals, programmers, or some other people like open source. But the main drawbacks of these two OS is that since this is not commercial product, so they are kind of not that user friendly. So if you want to install new hardware, probably this new hardware cannot be recognized by this two operating system. And also there are many tools. They only have a Windows or Mac OS version. So if you want to use these two OS, you may have no option. So next is the Chrome OS. Chrome OS, I think it's just recently released by Google. So it's kind of like a mobile OS, but it's more close to desktop because the purpose to help you to deal with the desktop applications. Then we have our server OS. So in server OS, so the Windows Server OS is still one of the, I would say, the popular OS in this category. It is because that many Windows programs can be directly without any change to be run in this Windows Server OS. So that's the big advantage. For the Mac OS server, so it's not that popular, but still some people use that because the Mac OS actually is based on the Unix, so it's kind of stable. The problem is that it still can be run in the Apple machine, so that's kind of a limited usage. So next is the Unix and Linux. Actually, Unix and Linux, their main advantage is on the server side, because since they're open source, so our expert programmer developer can make this OS super stable. So that's why the majority of the routers or servers, they are running either Unix or Linux system. So if later you want to be like service maintenance, whether as a developer or IT infrastructure developer, you may deal with this Unix and Linux all the time. So let's move on to the mobile OS. So for the mobile OS, the two most famous or most people used are Google Android or Apple iOS. So these two are the, I would say, occupy the most of the market currently. Why is like that? It's not only because they are easy to use, they are resource efficient. The most important is the ecosystem. So in these two OS, we already have so many apps already. So, and developers and programmers, they intend to publish their software in these two platforms. So that's why it makes things like this right now. Actually, the Windows Mobile version, we call it the Windows Mobile. I used that before. Actually, still very good, very stable, and very easy to use. But the main problem for the Windows Mobile is that the many apps are missing in this platform. Especially there's many like the commercial apps or the bank apps. You cannot find a Windows Mobile version. So that's why, like I remember it's like last year or 1 year before, the Windows Mobile totally quit from the market. Now we know that we have many options now in the market about operating system. Here we can divide them into three main categories. So first is called the single program OS. So single program OS only support one program at the same time. It means that if we run one program and if we want to run the second program, we have to shut down the first one, then we're allowed to run the second one. So the main example will be the Microsoft DOS. So the MS-DOS actually was very popular in the last century. So most of the computers from last century, like not late century, but in the like 80s or even 90s, they have this MS-DOS. I remember my first computer is running on this Mac-DOS. So it is kind of it's not based on the graphic. So you don't have a like mouse to click. So everything is based on command line. So that's why it's not that user friendly, and you have to memorize many different commands. Like even for the copy paste, it's not that straightforward. And the biggest problem is that it only allows one program at the same time. So if you are doing your spreadsheet or you're playing game, you are not allowed to listen to music. So that's the main drawback. And the next category is called multi-programming or multitasking OS. So I would say most of the modern OS, they are fall into this category, like our Windows 10, Windows 7, or even Mac OS. They're all this kind of a OS because it allows more than one program to run at the same time. So the last is called the multi-processing OS. So this type of OS allow to use 2 or more CPUs within one single computer system. So I would say the most modern like operating system like Windows 10 or most of the server OS, they are like multi-processing OS. And this multi-processing OS can be further divided into 3 subtypes. So first is called multi-processor OS. It means that this OS supports multiple CPUs in one system. The second is called the multi-computer OS. It means that you can put several computers together, like connect together as a local LAN. So you can run this multi-computer OS like this one computer. So, but actually have a like more than 2 computers. That is called like a distributed OS. So this OS is more advanced. So it means that you can have your computer with the multi-computer. You have to put your computer at the same place, connect with them with cable as a local LAN. But for the distributed OS, actually you can have your computers all over the world. They can locate it in the different places in the world, but you can still run as the same computer. So it means that you can it is able to process much complicated tasks. And then what are the functions of our operating system? So the main functions of the operating system is to coordinate all activities among computer hardware. So I've given a lot of examples of the functions about OS, like start and shut down a computer, or provide a user interface, or like the monitor performance, facilitating network, like prioritize our system requests, memory management, which is one of the most important things about our OS, control input and output devices, file management, and like updating operating system software, power management, or admin security, or backup and restore. So everything is about our hardware is the task of our OS. So here, why I circle these 4 functions? Because these 4 functions are fundamental functions for an OS. Because for an OS, it has no monitor, has no network connectivity, has no admin security, even no backups, but it has to have like the prioritizing the system requests and has to deal with memory management. Otherwise, this system can even not be run. And also has to deal with the like the input and output devices, and also it has to deal with the files. So that's the 4 fundamental functions for an OS. So the next very important function or feature about our operating system is called virtual memory management. So why virtual memory management is important? Because it can save our RAM size. Why is like that? Since we know that RAM is very expensive, like for the hard drive, we can easily have a size with 1 tera or 2 terabytes. But for RAM, currently we can only have like what 8 gigabytes or 16. I would say that's a lot to some normal people. And we know that to run a program or run the software, these software or functions are running in the RAM because the speed of the RAM is faster than the hard drive. But actually, nowadays, due to the multitasking system, people intend to open many programs at the same time. So more programs to be opened, and it will occupy the RAM size. But if you keep on opening, so until some time, so all the RAM will be fully occupied. So when the RAM is fully occupied, and if you still want to open your new program, now it's time to use the virtual memory management function. So step 1, our operating system will transfer the least recent used data or program instructions from the RAM to the hard drive, because now the RAM should be used for the new program. But later, if you want to use the old program which has been opened, then our OS will transfer the data or the program from hard drive back to RAM again. So now you are allowed to run the old program you used to open. So one example from daily life is that if you open your browser, you open like many pages. So, but if you can't continue opening new pages, if you want to browse the old pages you used to open, you'll feel that actually this old page start to be very slow because these old pages are already transferred from RAM to the hard drive already. So that's why it's very slow. But later, this old page will be very smooth again because our OS they transfer the page back from the hard drive to the RAM again. So that's one example for virtual memory management. So here I will give a more detailed example about how does virtual memory management work. So let's assume I have this computer. We have 3 types of software. The first is called a spreadsheet. Second is a web browser. The third is the virus scanner. So we use S to represent the spreadsheets, W for the web browser, V for the virus scanner. For the spreadsheet, you use 800 megabytes of the RAM, web browser 400, scanner 200, and our computer only has 1 gigabyte RAM. And why here we said ignoring OS, because usually the OS itself it will always occupy some of the RAM, but in this case we just ignore this part. So step 1, initially we have our spreadsheet and a virus scanner in our memory. So it's like this feature. So we have our spreadsheet and virus scanner, and then we open our web browser. So web browser running, and we just read part of the web browser in it, because usually in the beginning we don't need the whole web browser. So here we just need part of the RAM to reading the web browser. Then we just transfer some spreadsheet data from RAM to the virtual memory to make some room for the web browser. And later, since we may maybe open more web browser to open more pages, so at this time we need more RAM. So then we move some more RAM size from the spreadsheet and put into the virtual memory, and then we give more RAM space to the web browser. So let's move on to the next important feature about the operating system is scheduling jobs. So for scheduling jobs, so OS determines the order in which jobs are done. And also, not always first in and first done, because the different jobs will be given different priority and different resources. So that's why some jobs has higher priority. So this can be done manually, you can set this like software to be run at a high priority. So you can try that in your own windows. And some jobs is given by higher priority by default, because for some many like system level software, they are given very high priority. For example, the network software, or like you will send something to print, this kind of printer service, they have very high priority. And like several popular OS have a scheduling algorithm to deal with the resources to given to different jobs or different tasks. So first one is the very simple one. It's called the first come first serve. So which program is open in the first place, the resource will give it to it. So once it finishes, the resource will give to next. So that's called one first come first serve. So next called the round robin. Round robin is also very simple scheduling algorithm. It means that if you have like the software ABC open at the same time, so the OS will give, firstly, we give the resource to A. So after a while, then the OS will give the resource from A to B, and then B to C, and then from C back to A. So it's like this. So that's called round robin. Next is called priority scheduling. So just like we introduced, so some tasks are given very high priority. It means that this job is very, very important. So in this case, our OS will give much more resources to this kind of tasks with high priority. Next is the shortest job next. So since we have many tasks or jobs running in the system, so different jobs has different requirement about the resource. So if this jobs has the smallest or shortest resource requirement, so our OS will give the resource to this shortest job. So that's called the shortest job next. Then is the shortest remaining time. It means that many jobs are opened, but since different jobs require different time to finish the task, so the OS will measure how many times for software to finish the work. And so the software has the shortest remaining time to finish the job. So our OS will give the resource to this kind of software. So that's called the shortest remaining time. It means that just finish your job as fast as possible, then go. So that is the meaning of this algorithm. So last is called the multiple level queue scheduling. So this scheduling could be the combination of the previous scheduling, because in this case, our OS will create like multiple queues and puts the jobs into different queues based on some properties like the memory size requirements or CPU time requirements. And for each queue, it can use different scheduling algorithms. So that's the multiple queues algorithm. So next is spooling. Spooling is one method of copying data from one device to another when the speed of one device is considerably greater than another. The example is print spooling. So if we want to send something to print, we send the print drops to a buffer before they are printed. The processor is much faster than printer. So the process writes to the disk buffer first, and then the printer will read the data from the buffer as required. So this method will increase the processor and the printer's working efficiency. Why is like that? Since, as I said, the processor, the speed is much faster than the printer. So if the jobs is given from a processor to printer, since it's very slow at printer side, our processor have to wait until printer receive all the jobs. So it will waste a lot of time for the processor. But if the processor just throw all the jobs to a buffer and then go to do something else, then the printer can get information from the buffer whatever the speed it is, that has no effect on the processor. So usually in the buffer we have a queue. So all the print jobs will be put into a queue and wait for their turn to be printed. So that's the technology called the spooling. Now we have finished the introduction to the operating system. Let's move to the next important system software called the BIOS, Basic Input and Output System. So to enter BIOS, actually BIOS has been installed in all the computers. So every computer has this BIOS. So in order to enter the BIOS, different computers have different settings. So when you turn on your computers, you can press some is delete, or some is escape, or function 2 or function 8, depends on your own computer. So what does BIOS do? When you turn on your computer, BIOS will do the post operation. Post means power on self-test. It's to test your computer hardware and make sure that no hardware errors. It means that the memory stick has been correctly inserted, hard drives there, CPUs working fine, something like that. Then BIOS will do the initialization. It will initialize hardware parameters and config the hardware status, make sure that computer is in the ready state. So after all the parameters has been correctly initialized, the next step is to boot the system. So we all know that Windows has been installed already in the hard drive or other operating system, but our CPU does not know where our Windows is located in the hard drive. So that's the job of the BIOS. So BIOS will locate the operating system in our hard drive. Once the system has been located, the BIOS will pass the control to the operating system. So many people like to play with BIOS because here you can play with many low-level hardware parameters. For example, you can set up a computer password. So this password is different from Windows password. So this password is safe in your CMOS, and it's not easy to remove if you forget your password. Also, you can configure time and date and save in the CMOS. You can also change the booting order of your system. So you can boot your system from your hard drive, boot the system from the flash drive, or from CD-ROM. You can also boot the system from the networks. And another thing is that if you want to overclock your CPU, you can use BIOS to change the frequency or even the voltage of the CPU. In this way, you can easily overclock your CPU. So that's interesting about BIOS.
So next is device drivers. A device driver is a software program allowing higher level computer programs to interact with a hardware device. So device drivers can work with the operating system or without operating system. So that is not strictly required. In this example, we have our computer has the Wi-Fi dongle, and we want to use our browser to browse the internet. So how it's like that? So we have our browser like Google Chrome, and it is installed in the Windows system, and then we have our device dongle. So usually between the operating system and the device, which is a Wi-Fi dongle, we have the hardware drive in the middle. So hardware drive will get data from the hardware device and transfer the information to our Windows system. So that is the usage of the device driver. Device driver is very important since in this case, it's very simple, but in some other more complicated hardware like our graphic card. So if the driver is not correct, if the parameters in the hard drive is not correct, we may have our graphic card may not work in the perfect condition. So if we want to play not the high-end, the AAA games, you may experience the low quality image or even like the laggy gaming experience. So to have the correct version of your device driver is very important. So for a device driver programmer, it's not easy because you should not only understand the programming skills, how to work with the operating system, how to work with your application software, but also you need to have a fully understanding about your hardware as well, like the hardware register, hardware architecture, yeah, something like that. So yeah, it's kind of challenging, but it's interesting work. Then is the utilities program. Utility program is a system software which is designed to help analyze, configure, optimize, or to maintain the computer. So I'm pretty sure that many of you has used this Unity software before. So like many Unity software in our Windows system, like the disk defragmentation or software updates or system cleanup, encryption, decryption, like fast encryption, decryption, and also the antivirus software. So they are all one kind of Unity software. So the last system software is the programming language compiler or disassembler. So how does a compiler or disassembler work? So here is an example. If you want to print a hello world to in the screen our computer, so how can we do that? For the computer, it doesn't understand what does hello world mean to a computer, as we talked before. It only understands zeros and ones. So how to make this happening? First, we need to find our programming language. Here we can choose C as our programming language. Then we type the code, print hello world. Then we send this code to the compiler. Then the compiler will translate this C language to another intermediate language called the assembly language. So compare with the C language, assembly language is closer to the hardware because it play with the register. So here is example, the push move. So push is to push the stack to this register. Move is to move the value from this register to that register, and then that's do the calculation. So that is the assembly language. But actually, the assembly language is still not the only ones. So our CPU still cannot understand what does it mean. Then we need the next one, assembler. So assembler will further translate assembly language to the 0 and 1s. We call it machine language. So finally, our CPU receives all the 0 and 1s. Then it understands what does it mean and print the hello world in the screen. So this is all about the compiler and the assembler. Until now, we have introduced the software and operating system. Then let's move to the next topic, digital security. Actually, the security, this topic is very huge. In this subject, we only touch the surface and give you some fundamental knowledge. In the future, you may have some other subject to learn more about security. So what is the definition of a digital security risk? It means that any event or action that could cause a loss or damage to a computer or mobile device hardware, software, data, information, or processing capability. So all this means digital security risk. So actually, we may have this kind of a security risk every day. For example, we may have unauthorized access to our system, and we may have internet or network attacks. So this kind of attack will bring our network down. Also, we may have the system failure, which is caused by lightning strike, or our computer may be compromised by some hand attackers. So they can steal our personal data, like our credit card information, ID information, or we may have the thief in the hardware shop. They will directly steal the computers. And also we may have many hackers. They try to hack the software directly without buying license. All this kind of behavior we call the digital security risk. First, let's talk about internet and network attacks. In this category, there's a very important concept called malicious software, which is malware. Malware are the programs that act without a user's knowledge and deliberately alter the operations of the computer and the mobile devices. Nowadays, there are many types of malicious software, such as virus, which you may heard of this name most of the time, worm, Trojan horse, rootkit, spyware, ransomware, and adware. So I will go through this one by one. So first is virus. Actually, virus is a kind of a general name, indicate that all the program can affect the computer and may damage the files and the system software. We call it virus. And this term is first appear in the last century, 1982. So the first virus is just like a pram. It doesn't harm our computer, just make some jokes with the users. But later, the designer found that actually they can use virus to do many like the malicious behavior. They can steal people's information to hack the system, and then the virus become more and more popular. So next is worm. So worm can copy itself repeatedly, using up resources and possibly shutting down the computer or network. It can send copies of itself across a network, affecting other computers, whereas a virus needs to be attached to a program, but worm do not. So actually, worm is a subset of the virus. As I point out, virus is less dangerous because it needs to be spread by some program. For example, if you download a hacked program, a hacked game, it may contain virus. But worm is not spread in this way. Worm is usually embedded into the website or email. So once you browse some like unknown website or you open some like unknown email, then you will get affected by the worm like in high visibility. And it's not easy to clean or kill the worms because if you just kill worms in just one single computer, but this computer is still connected to the internet or connected to the other computers, but this worm may come back. So the only way to kill worm is that disconnect your computer and download the latest antivirus software. And we should do this in all computers. And that's not an easy task. And this gives you the hint that never visit those unpopular, unknown websites, because usually this kind of website, they are badly designed and they contain a lot of bugs. So worm will get affected easily. But even for those famous big websites, since we are just human beings, we made mistake all the time. Even for those big and famous websites, they still may contain worms, even very low possibility. So it means that for us, if you go to internet, you'll be highly possible that you get affected. So the only way we can do is that we just need to keep our antivirus software up to date and don't put our critical information in the computer, just in a separate place. So that's the only thing we can do. So next is a Trojan horse. A Trojan horse is actually a malicious program that looks like a legitimate program, but when executed, it can erase your files and can damage your hard disk. So different from worm, Trojan does not copy itself. They use to gain unauthorized access to a computer, such as data theft or keystroke logging. In my opinion, Trojan horse is even more dangerous than worm. Why is like that? Because Trojans is not actually a virus. So for many antivirus software, they cannot detect Trojans. And once you get affected by Trojans, this Trojan will open a backdoor in your system. So those attackers or hackers can directly have a full control of your computer. They can download your data, they can steal your information, and they can even download those viruses and worms to your computer directly. So that's so that's why Trojan is very dangerous. It's very hard to detect and how to defend. So the only way to defeat the Trojan horse is to download the software from the official website. Never download it from some other third-party website, and always run the program which is we have full control of it. You know where it's from. So in this way, you can lower the possibility to get the Trojan. But still, it's very hard to get rid of it like 100%. So next is rootkit. Rootkit allows someone to take a remote control of the computer as an administrator without user's knowledge. So the rootkit may exploit some known vulnerability of the operating system to gain access. So rootkit is kind of like similar to Trojan, but the main difference is the way of threading. So Trojan is much easier to get affected because it's just spread in the internet. But rootkit is not that easy because rootkit is actually act like a virus, should be embedded into some software. So that's why rootkit is less dangerous than Trojan, but still a big threat to our daily life. Next is the spyware. So spyware will secretly obtain the information about the computer or the user without the knowledge. So spyware is different from rootkit because spyware does not need to have the full control of your system. And another thing is that actually many software that are spyware, it's hard to tell the boundary. For example, Facebook. Is that spyware? Because you enter all your personal information into Facebook. But do you have any idea how people use your information in Facebook? It's the same as Instagram, Twitter. So some people say that's spyware, but don't depends how defined spyware. And next is ransomware. So ransomware is a program that blocks or limits access to the computer, phone, files until the user pay a special amount of money. So if you remember what happened in 2017, there's a very famous ransomware called the WannaCry. So actually, this software just lock your computer and lock all your files. The only way to unlock your computer is just to pay high amount of money, like the bitcoins, to the attacker, and then they will unlock your system. So this is called the ransomware. So the last is called adware. So adware is a program that display an online advertisements. Actually, there are many kind of this kind of a program. Even some like good program, they contain this adware because they're usually free. So if you to use this software free of charge, they are required to watch some like advertisements. So it's very hard to tell if the adware is malicious software or not. Depends how annoying it is. Next concept is called bootnet. Bootnet is a group of compromised computers or mobile devices connected to a network. And a compromised computer or device is also known as a zombie. So if one hacker is managed to hack too many computers and has a huge number of zombies, and then we'll call it zombie army, just like here. Actually, zombie army, they are very, very destructive, and many of the security risk and security accidents are caused by zombie armies. And how does zombie army work? And here is the botnet architecture. First, we need to understand how zombies communicate with each other. There are two ways. First is called peer-to-peer network. So zombies can directly talk to each other without any server or clients. The other is called client and server mode. So one zombie will act as a zombie server. It will send comment or data to some other zombies as a client. And all these peer-to-peer zombies or client server zombie, they all controlled by one or several bootmaster, which is attacker. And all these zombies Usually they act as a normal computer, and even as a user, it cannot feel that their computer are zombies. So once a attack plan is made, usually by the bootmaster, for example, he wants to attack some banking system, banking website, this bootmaster will send a command to all the zombies. This command will contain the website address of the banking system, the banking website, and at what time these zombies should attack, and also how frequently this zombie should attack. So when zombie receives this comment, it just goes to sleep mode, and the zombie will be activated when the time is up. So that when the attack time comes, those zombies, like thousands of zombies, will send rubbish requests to this banking system. So even for a very robust banking system, if it receives thousands of requests at the same time, it will crash, and or other normal user can have no access to the banking system. And this kind of attack we call DDoS attack. So actually, I will talk about the details later. So before we introduce DDoS attack, let's first look at DOS attack, denial of service attack. So denial of service attack means that attack meant to shut down a machine or network and making it inaccessible to its intended user. So denial of service can be accomplished by flooding the target with a huge number of traffic or sending some information that can trigger a crash. So often target web servers of the high-profile organizations such as banking, commerce, or media companies, or even governments or trading organizations. So these targets are often the web server from the high-profile organizations such as banking, commerce, media companies, or governments, and some trade organizations. So there are many ways to do the DDoS attack. I just list 3 famous ways to do the DDoS attack. First is called the buffer overflow attack. In the buffer overflow attack, attackers need to send more traffic to the network address than the programmers have built the system to handle. It means that actually the system has some buffer to deal with the request. But if we send more traffic than it can handle, this system will crash. So the second is called ICMP flood, also named as a ping flood. Probably you have used this ping command before to ping some website to see if it's live. But in the ping flood, attacker takes down a victim's computer by overwhelming it with the ICMP echo request, also known as a ping request. So if we will ping a website many times, like more than 1,000 times per second, this website will be overwhelming by the request because it cannot handle so many ping requests. But actually, this kind of attack is very easy to be defended. So you can think about that. So the third is called SYN flood. So SYN flood is that we send a request to connect to a server, but never accomplish the handshake. So continuously until all the open port has been occupied with requests, and none of will be available for the rest of the user to connect. So this same message is from the protocol TCP. So you will learn this protocol TCP later. Now here I just give you some very brief idea about how that SYN flood work. So here, let's see if we have this attacker and a server. So if we send the same message, at the server side, it will receive the sync, and then it will open a port and make it available for us. And then it will send back a response. But if we don't like care about the response, we keep on sending another thing. Then the server will open another port for the new thing. But if we just keep on sending the same results, accomplish the whole handshake, because handshake will take several times. But if we don't complete the handshake, so the server will continue to open many ports. But actually, for the server, the port number is limited. So if we just keep on sending until all the ports are occupied, actually there's no port available at the server side. So even now there's a normal user want to send a request to the server, since all the ports are already occupied, so the server cannot do a service to this normal user. So it means that now this server is denied of service. So the next level of the DOS attack is called the DDoS attack, distributed denial of service attack. Compared with the previous DDoS attack, DDoS attack is much more dangerous, destructive, and effective. So why DDoS is effective? Because it does not take advantage of the existing protocol like the ping or sync. It just uses the normal way to visit this website. And here we have all the zombie computers, and here we have the controller. A computer for this controller computer is also a compromised computer, but attacker won't send commands to these zombies directly. Usually, attacker will hide behind a controller, so it will be hard for us to find who is the real attacker. So once this attack plan is made, for example, the attacker want to attack some websites, as I said before, it will send a command to the controller. And then controller will send this command to all these zombies to let them know that when and where to attack. So when time comes, all these zombies will send requests, like normal requests, to this victim website. Like if we have thousands or millions of zombies, this system will crash immediately. So that is a DDoS attack. So it's very hard for us to define this kind of a DDoS, and also it's very hard for us to find who is the real attacker. So that's the big problem right now in the whole world. So next is the backdoor. Backdoor is a means to access to a computer system or encrypted data that bypass the system's customary security mechanisms. For backdoor, there are two types. The first type is deployed by the attackers. So the attacker will send a backdoor program to a target system by either the rootkit or the Trojan horse. So once the backdoor is installed in the computer, so the backdoor will check which port is allowed to access, and then it can access to some servers and steal some information. So that's one type of backdoor. So the second type of backdoor is actually made by the company who build the system. For example, Microsoft. So in Windows, we actually have the backdoor, but we don't know where it is. So it's just hidden somewhere. So why we have the backdoor in Windows? There are many reasons. Some reason may from Microsoft that they can use this backdoor to update your system. They can track their product. The other may be some like political reasons, and we never know. So that's why in many government levels computer, they don't use Windows, especially in the countries rather than America. They prefer using Linux because Linux is fully open source. So the government can have a full control of the system without have any backdoors. So the next type of attack is called a spoofing attack. So the spoofing attack is also called the man in the middle. So the attacker just pretend to be a normal server, but the victim does not know that. So the victim will send this request to this fake server. So attacker will forward his message to the real server, and then real server will send back the request, and then the attacker will send the request back to the victim. Yeah. So in this way, attack can obtain all the information between victim and the server, and both victim and server does not know there's a man in the middle that exists. So we can do both IP spoofing or email spoofing. So IP spoofing that all the traffic from the victim to the server will go through the attacker. So the email spoofing is that if the victim wants to send an email to the server, it just actually send this email request to the attacker. So attacker will forward these requests to the email, and then the attacker has full access to the email of the victim. Then how can we protect our system? There are two main methods. First is to install the antivirus software. So here we have so many options about antivirus software, and they have both strengths and cons. So probably have usage one or several of them. But you should bear in mind that no security software is guaranteed to detect or find all malware. So one reason is that actually this kind of virus or worm or Trojan horse, they are evolving all the time. So the new malware will be generated from time to time. So it will be very difficult for the antivirus to detect all this newly generated malware. The second reason is that those malware, sometimes they are hidden very well, and some are, it's hard to say it's malware or not. For example, the Facebook, some say it's a spyware, but I would say no antivirus will think that Facebook is a malware, right? So that's the reason. It's very hard to define the boundary. What is a malware, what is not. So the second method is called the firewall. The firewall we can consider as a list of the rules, which is embedded into our router. So for our internet, it all connect to the router. If one of them want to have access to the internet, it has to bypass this router. Then we can set rules to filter out all the traffic. For example, we can only allow the connection initialized from the inside, but not from outside. So then we can prevent the outsider, some attacker want to have the access to the internet. But there's also drawback about the firewall, because if we set too many rules, then some normal traffic may be blocked. So for example, if you want to send an email, but the email port is blocked by the firewall, then you will never receive an email. Yeah, similar like that. But if you have the few rules, then the firewall doesn't make any sense. So that's a trade-off between like how many rules we set in the firewall. Next is the unauthorized access or use. We may have unauthorized access. It means that the use of the computer or network is without any permission. Or we may have unauthorized use. So the use of the computer or its data is for unproved or possible illegal activity. Some organizations take several measures to help prevent unauthorized access and use. So the first method is to use an acceptable use policy. We call it the AUP. So AUP is an agreement between user and the service provider that defines how users are allowed to use the service or network. It contains both acceptable or an unacceptable behavior. So actually this AUP works very well because many kind of risk is not caused by our computer or our hardware, software. It's actually caused by our human beings, because sometimes people are careless and use something without any permission and cause a problem. So this policy will limit the behavior of the user and make everything safe. So the second method is kind of harsh. Just directly disable the file or the printer sharing, because sometimes people did not follow the policy and cause problem. So in this case, we just directly disconnect the network, disable all the sharings, and make our system safe. Then about access control. Fuck. So the second method is called the processed object. So we can use badge, cars, keys to have the access control. The main problem of this method is that this badge, car, and key are not like binding with the user. So if you, for example, if you lost your key, so if other people get your key, so it can have access to the resource. So that's the main problem. So the third method is to use biometric devices such as a fingerprint reader or face or voice recognition or even signature or gesture. So this method is very, I would say, effective, convenient, and binding the information to the user. Because it will be hard to steal some other's fingerprint. But the main problem is that this method may be not that accurate. For example, the face recognition. So in early stage, people can use some photos to cheat the system and bypass the access control. For example, the signature as well. If one people can perfectly copy your signature, then system have no way to prevent this from happening. And then let's talk about protecting software and information. Then how can we protect our software? Actually, there are three main methods. First is based on hardware. Second is use the serial key. The second is online activation. So hardware-based protection is very effective, but kind of costly. For example, we can use this USB dongle to protect our software. So once we open the software, it will ask us to insert the USB dongle, then will allow us to use this software. Or we can ask the user only use some specific machine to use this software. But the problem is that if we want to install this software to some other machines, which is not possible, which makes things complicated and inconvenient. So the second method is serial key. Serial key has been used many years because it's just simple, easy, and low cost. So when you buy a new software, they will also give you this serial key. So when you install it, you need to enter this key. Once the installation is complete, they will compare the key to see if they match. So the main problem of this key is that if you buy a software, you can share it with the key with other user, and it's very hard to find how many users install this one to use the same serial key. That's why then the third method comes, online activation. For online activation, we can combine several methods. Like we can use the serial key, we can use the license file, we can use the username plus the password. And once we enter this information, the software will connect to the server to check how many times the key has been entered, is the username and password valid. And now it's considered to be the most effective method, but only problem is that it increases the cost because you have to set up a special server to check all these keys, license file, and username and password. And for those machine without any internet connection, that will be a problem. So all these protection method, they both have, they all has a pros and cons. You should choose one of them. Depends on your situation. Then it's about the information protection. How can we protect our information? So the main method is to use encryption algorithm. So encryption is a process to converting data that is readable by humans into coded characters to prevent unauthorized access. There are two ways to do the encryption. First is called symmetric encryption, and the second is called public key encryption, also called asymmetric encryption. So for the first symmetric encryption, so both communication parties must have the same key in order to achieve the secure communication. So the most famous one will be AES 128. So this encryption method is very secure. So the symmetric algorithms has been widely used because it's usually very fast, very safe. But the main problem is that both sender and receiver should have the same key. So they should must agree on the key in the very beginning. But what if the sender and receiver, they are far away and that's not possible for the sender to tell the receiver the key. Then we have the public key encryption method. So for the public key encryption, so the encryption key is published actually for everyone to use and encrypt the message by using the public key. And only the receiving party has access to the encryption key, which is called a private key that enables the message to be read. For example, the ISA encryption algorithm. And here is an example. So step one, the sender create a document and want to send to the receiver. It contains the confidential message. Step two, the sender will use the receiver's public key to encrypt this message, because this is a public key, everyone knows this key. So there's no secret. And then this encrypted message will send to the receiver. In step three, the receiver uses his private key to decrypt this message. Because this is a private key, so only the receiver has this key. In step four, the receiver can read or print the decrypted message. So the confidential message can be shown again. So in this example, even a third party get this copy, the encrypted message, it has no way to decrypt it because it doesn't have the private key for the decryption. So it's very safe. Since this public key encryption is so good, but why we still have to use symmetric encryption method? It is because the public key encryption is very complicated. It's based on very complicated mathematical problem. So in theory, this method is maybe 100 or 1,000 times slower than the symmetric method. So if we want to encrypt a large file, or we want to encrypt the real-time video, there's no way to use the public key encryption to do that. So that's why we have both as method to use. If you think about it, actually, we can use the public key encryption to transfer the key for the symmetric encryption. For example, if we want to use the symmetric encryption for the secure communication, then the sender can send the key to the receiver by using the asymmetric method. So once the receiver get the key, then it can use the symmetric method to go on with the secure communication. Next is a digital signature. A digital signature is an encrypted code that a person, website, or organization attaches to an electronic message to verify that the identity of the message sender. So digital signature is often used to ensure that an imposter is not participating in an internet transaction. So how to achieve digital signature? So you can think about that by viewing the topic I just mentioned. So that is a digital certificate. It is a notice that guarantees a user or a website is legitimate. So the last topic today is managing physical threats. So hardware theft, vandalism, and failure. So how can we prevent hardware thefts or vandalism? There's many ways. The most direct way is to have this kind of a physical access, to use lock or windows to prevent this from happening. Or we can use alarm system to put alarm in the hardware. Once it moves, we can trigger alarm. That is, we can use the physical security devices like cables, locks to lock our machine. Or we can use the device tracking apps. So when our device is moved, so the app will send us some alarm. And our hardware may also fail due to many reasons. For example, our computer may shut down due to the blackout. Then we can use UPS to prevent this from happening. Or if we have one computer down, we can have like a duplicated components or duplicated computers to make this still up and running. Or we can have this kind of a fault tolerant computer. For this computer, it's very robust. but usually it's very expensive as well. So in order to prevent this failure from happening, the most effective way is to do the backup. So the more commercial companies, they all have a different strategy to do the backup. And here is a list of all the backup types. For example, the full backup. Then we need to copy all the files on the media into the computer. So it's very, we'll say it's very safe and very fast because we just copy back everything. But the problem is that it will take a long time to the backup because we need to backup everything in the system. So in order to increase the efficiency, we may have differential backup or incremental backup or selective backup or continuous data protection or even a cloud backup. So all these backup can be used in different scenarios and they all have pros and cons. In this lecture, I won't go to details. You can read it by yourself. Last, let's talk about wireless security or Wi-Fi security. Since wireless signal can be received by everyone, so how can we do the access control? So the most effective way is to use password and encryption. So you may have this experience that if you want access to a new Wi-Fi network, you have to know the password. And the other way is to use the MAC address control. It means that the Wi-Fi router only allows some predefined MAC address to have access. So other new computers with some other different MAC address, they are not allowed to have access to the network. So that is the end of today's lecture. Thank you so much. If you have questions, please send me email, and then we can set up some Zoom link for discussion.